All right, let's jump right into this. Welcome to The Explainer. Today, we're exploring a truly fascinating hidden world, the life after death of our discarded electronics. We're going to uncover what really happens when you give old tech a second life, and we'll be zooming in on an absolutely incredible movement happening right now in Nepal. As we'll see, the ultimate form of sustainability isn't just about saving the planet, it's a massive social mission that is actively closing the digital divide for students in rural classrooms.
But before we travel across the world, I want you to take a second and think about your own space. Seriously, be honest. What's gathering dust in your IT closet right now? Or maybe in that bottom drawer of your desk? An old smartphone? A laptop with a totally dead battery? Maybe a giant, tangled ball of charger cables? For most of us, those forgotten items kind of feel like the end of the line. But I am here to tell you that dusty drawer is actually the starting point of an incredible and incredibly valuable journey.
Because listen to the sheer scale of what we're dealing with globally. In 2022 alone, the world generated a staggering 62 million metric tons of electronic waste. That's enough to completely boggle the mind. Experts aren't just calling this a problem anymore. They are literally calling it a tsunami of e-waste. And a tsunami is exactly what it feels like when you realize that every single year, this mountain of discarded screens, batteries, and boards just keeps growing, threatening to completely overwhelm our global waste systems.
Section 1. The E-Waste Tsunami, Weighing the Problem in Nepal.
So let's focus on Nepal for a minute. In 2023, the nation generated 42,000 tons of electronic waste. Now, when we hear numbers in the tens of thousands of tons, it can be really hard for the human brain to actually picture what that looks like, right? It just sounds like, well, a lot.
To put the true weight of that problem into perspective, 42,000 tons is roughly equivalent to a herd of 7,000 elephants standing together. That is the physical mass of dead electronics Nepal dealt with in just a single year. And without scientific, formal handling, these heavy metallic elephants don't just disappear. They end up discarded in local landfills, dumped into rivers, and leaching right into the soil.
Which brings us to the absolute most dangerous part of this waste. We're talking about lead, mercury, and cadmium. Now, these aren't just elements you memorized on a periodic table back in high school chemistry. In the context of e-waste, they are hidden poisons. When an old laptop or server is improperly disposed of, these toxins escape. They seep into the earth, leading directly to groundwater contamination, which poses a really severe threat to both environmental and public health. So, who's actually handling all this toxic material right now? Well, regionally, about 95% of e-waste is managed by the informal sector. And that often looks like hazardous open-air burning, where workers literally melt down plastics and metals without any protective gear, releasing deadly toxins straight into the air. But a powerful contrast is emerging. The formal sector, pioneered in Nepal by facilities like Doko Recyclers, provides safe, scientific material recovery. It's a crucial shift from a highly dangerous reality to a structured solution that actually protects the environment and the frontline workers.
Section 2. Inside Nepal's urban mine, unlocking the value in waste. Because here's the thing, e-waste isn't just a hazard. It is a massive, totally untapped resource. This concept is called urban mining. Instead of tearing up the earth with destructive traditional mining to find new materials, we recover valuable, precious metals directly from the electronic waste we've already created. Formal facilities don't look at a broken server and see trash. They see an urban mine. They see an incredible opportunity to extract resources that are sitting right in our cities.
Consider the sheer concentration of wealth we're throwing away. Get this, 1 ton of smartphone printed circuit boards, or PCBs, can contain up to 100 times more gold than a ton of actual gold ore dug straight out of a traditional mine. Let that sink in for a second. 100 times more gold. This proves that circularity is not just some environmental buzzword, it is a highly valuable economic strategy that dramatically reduces our reliance on destructive earth mining.
Section 3. The data security barrier. Why companies hoard old tech.
So you might be wondering, if these devices are so valuable, why aren't corporations recycling them by the truckload? Well, it usually comes down to one massive roadblock: data security. There's this super common myth in the corporate world that e-waste is safe if it's just locked away in a basement storeroom. Let's debunk that right now. Hoarded electronics are a physical fire hazard, especially as those old batteries degrade, and they are a massive cybersecurity risk. When a company hoards laptops, they aren't protecting their data. They are actively creating a liability. And what's worse, every single year that device sits idle, it loses its upcycle value.
But there's a better way. Here is the technical journey a corporate laptop actually takes to become a secure solution when handled correctly by a formal facility.
First up, a secure disposal audit figures out exactly what's there. Second, and absolutely crucial for businesses, is certified data sanitization. Using incredibly strict protocols like NIST 888, this step guarantees the data is gone forever, completely protecting corporate reputations. From there, the device moves to material segregation, sometimes even using AI to sort components. And finally, we hit the ultimate goal, refurbishment.
Section 4. From junk to school desk. Giving tech a second life.
That final step, refurbishment, is the real emotional core of this entire movement. In Nepal, an incredible initiative called the Recover, Refurbish, and Reuse Project, or simply the RRR Project, recently hit a massive milestone. They successfully distributed 206 fully refurbished devices directly to under-resourced communities. We're talking about students and teachers who otherwise just wouldn't have access to this vital technology.
Their mission statement summarizes it so perfectly: closing the digital divide, one device at a time. This is where the social mission truly shines. Seeing a retired laptop from some corporate office suddenly powering a rural classroom and giving students access to the whole digital world, well, it proves something vital. Repair and refurbishment are the ultimate forms of sustainability. It's not just about keeping plastic out of a landfill. It's about real human impact. And what's amazing is that scaling this kind of life-changing impact is actively building a massive global industry.
Section 5. Building a circular future. Career paths in a $62 billion market. A huge driver of this growing job market is a massive policy shift called Extended Producer Responsibility, or EPR. EPR laws are essentially forcing tech brands and manufacturers to take legal and financial ownership of the entire life cycle of their products, right down to the recycling costs. Because of this, brands have to completely rethink how they make things in the first place, focusing heavily on design for disassembly, so products can be easily taken apart later. And let me tell you, this policy shift is creating thousands upon thousands of jobs.
The circular economy offers a highly structured career roadmap. Over a decade, you can go from building your foundation in compliance to mastering urban mining technically, straight through to directing sustainability strategies, and finally leading market innovation as a chief sustainability officer. You can literally go from an entry-level auditor to an industry leader owning a piece of that $62 billion market in less than 10 years. How cool is that?
And the leaders of tomorrow are going to be managing some mind-blowing innovations. The future of e-waste includes AI-driven sorting systems that bring massive, unprecedented efficiency to recycling facilities. It includes scaling up lithium-ion battery recycling to safely extract black mass. That's the highly valuable mix of cobalt and lithium essential for electric vehicles. And by 2025, we'll see the rollout of digital product passports, creating a totally transparent, traceable identity for the materials inside our electronics.
So we've seen the global tsunami of waste, the hidden gold inside our circuit boards, the vital importance of data security, and the beautiful reality of a refurbished laptop empowering a student in Nepal. The circular economy is here, and it is a powerful social mission. So I'll leave you with this. The very next time you open that dusty IT drawer, will you leave your tech to die, or will you give it a second life?